Welcome student in Christchurch Convent Digital Classes, Subject Chemistry, Class 11th, Chapter 2, Part 9. In this video, we'll see Bohr's theory, Bohr's theory of atomic model. According to Niels Bohr, atom is electrically neutral. That is, in any atom, the number of proton is always equal to number of electron. In the center of an atom, a dense body called nucleus is present, which is positively charged. In nucleus, proton and neutrons are present. Proton has positive charge and neutron has no charge. Outside the nucleus, there are cells or energy levels designated or named as K, L, M, and so on are present. In cells, electrons revolve around the nucleus and electrons are negatively charged. Each cell has fixed amount of energy, therefore they are called as stationary states or energy level. So these are the main postulates of Bohr's atomic model. The energy of the cell is given by the expression 2 pi square m e raised to power 4 n square h square. It is calculated to be minus 2.18 into 10 to the power minus 19 upon n square joule per atom. The radii of the stationary states are given by Rn is equal to A0 n square is called Bohr's radius, and the velocity of the electron in different orbits are given by Vn is equal to V0 into Z upon n, where Z is atomic number, n is the number of cell, and V0 is the threshold velocity of electron. So the energy of an electron is quantized. Q is equal to Ne. Only those orbits are permitted in which angular momentum of electron is the integral multiple of h upon 2 pi. The electron in its ground state neither absorb or emit energy, that is, it keeps on revolving in orbit without losing any energy. Energy is emitted or absorbed only when electron jumps from its lower state to higher state are called excited state. When electron jumps from lower state to higher state, it is called excited state of electron. The excited state of electron being unstable, electron returns to its ground state, and in doing so it emits or loses the absorbed energy, which is equal to E is equal to E2 minus E1. E2 is the energy of higher energy level or cell, and E1 is the energy of lower cell in which electron comes back. So what is the usefulness of Bohr's atomic model? It explains the stability of an atom. It also explains the spectrum of hydrogen, which others model can't do. Other atomic model can't do. For example, Rutherford. So you can see the diagram. Different series are showing here. This region from n is equal to 1 to 3. It is the emission region, and from n is equal to 2 to 4 it is absorption region, and from n is equal to infinite, n is equal to 1 to infinite, ionization also take place, and different series are found in different regions. For example, ultraviolet region, Lyman series are present. In visible region you can see Balmer series, and in infrared region you can see Paschen series. And for ground state the energy of electron is 0 electron volt, and for n is equal to 2 the energy of electron become 10.2 electron volt. For n is equal to 3 the energy of electron become 12.1 electron volt, and keep increasing and so on for different series. Now, explanation of hydrogen atom, hydrogen spectrum, hydrogen atom spectrum with the help of Bohr model. According to Bohr, when energy is supplied to atoms of hydrogen, the electron from lower energy get excited to higher energy level. Then excited state is being unstable, so it jumps back to its original state or called ground state. Some electron move their ground state in one jump, some electron do so in multiple jumps. So each jumps correspond to a line in a spectrum. So as we know, the gas in the tubes consists of many hydrogen atoms. Therefore, each electron on getting energy get excited. On returning to ground state, they either move single jump or multiple jumps. This is the reason that we get so many lines in different regions of hydrogen spectrum. The wavelength emitted by them can be calculated as, we know that the energy lost or gained by an electron from moving one cell to another is given by E2 minus E1, but E is equal to h nu. So, or nu is equal to E2 minus E1 upon h. We also know that nu is equal to C upon lambda. So lambda can be written as hc upon E2 minus E1. Now, limitation of Bohr's model of an atom. Bohr's model failed to explain line spectra or multi-electron atoms. He could not explain splitting of line into magnetic field, which is called Zeeman effect, and electric field, which is called Stark effect. So Zeeman effect and Stark effect cannot be explained by Bohr model of an atom. He failed to explain three-dimensional model of an atom. He was unable to explain the shapes of molecule. He could not explain the dual nature of matter and Heisenberg uncertainty principle. This led the discovery of quantum mechanics. Let us first understand the dual nature of matter and Heisenberg uncertainty principle that could not be explained by Bohr's model.